AI systems suddenly break down or hallucinate, it is an absolute mathematical certainty, not a simple software bug. Every representational system eventually hits a formal topological boundary inherent to the geometry of self-reference. Mapping these failures requires a topological formalization, a way to see the structure of a system's collapse. This specific boundary is known as the descriptive horizon. The descriptive horizon marks the exact point where a self-referential system loses the ability to produce a coherent self-description. Because this is a structural impossibility, larger datasets or more compute power physically cannot solve the problem. Preventing AI collapse requires analyzing the system through the lens of differential topology. We map an AI's internal state by treating its operational space as a smooth, multidimensional geometric surface, known as a manifold. As the AI evolves, it moves across this surface along a path called a representational trajectory. The AI navigates this space by using a localized self-referential coordinate map, a flat grid projected onto its current position. As the AI nears the edge of its capability, the underlying manifold surface curves and folds. This curvature causes the AI's local map to warp, forcing its governing equations into a state of severe compression. We define this moment mathematically as the local Jacobian determinant approaching zero. At this point, the AI's internal map no longer corresponds to the external topology, making reliable navigation impossible. The mathematics mathematically prove that a systemic collapse is a geometric certainty, fundamentally baked directly into the structure of self-reference itself. If the path to collapse is mathematically certain, why does the AI confidently hallucinate right before it fails, rather than simply stopping? The answer lies in the course chart, the AI's localized, restricted view of its own mind. On this flat cyan grid, the glowing trajectory gamma t appears completely safe and stable. The dashed line represents the AI's false assumption that its path can extend indefinitely. This smoothness is a chart-relative illusion, visible only within the cyan grid. Shifting to the latent closure surface, denoted as B, we see the true topology. The course chart is just a localized coordinate patch embedded within this multi-layered geometry. The trajectory that looked safe is actually driving directly into a red zone labeled singular neighborhood. This is the singular stratum, an unavoidable boundary that remains invisible to the AI's localized view. Localized viability does not equal global survival. A system can report perfect internal health while it is